Okay, so today's topic are lenses, and we're going to be looking at what they are and how they work. So first of all, what are they? Lenses are objects that manipulate light, and the purpose is to form an image. Um, the light bends as it enters glass. As you can see, the image would be over here, the object rather, and then the image would be right here. And then for this object or this lens, the object would be over here and the image would be right here. Now the reason light bends is because of the difference in the speed of light in air. So the main property that makes lenses work is refraction, but also the shape of the lens is key. Now their shape will determine um, uh, start over. Today's topic is lenses. We're going to be looking at what they are and how they work. First of all, what are they? They are objects that manipulate light to form images, like the lenses of these glasses, the lenses of this camera, um, manipulate light to form images. The light bends as it enters the lens because of refraction, and this is because light has different speeds in air than in the lens. Um, their shape is key. So the two properties that determine how lenses work are refraction, because of the difference in the speed of light, and the shape. Shape of the lens is key. Okay, so a lens will either bend light to converge it to a point or diverge it from a point. And we'll look at those two different types of lenses. Okay, so there's different ways of naming these lenses. One is based on what they do to the light. The other is based on their shape. So the first is a converging lens, and they're so called because they converge the light from the object. They converge it to a point. Um, and so because of the shape, now this diagram here shows the ray diagram for the parallel rays from the object that converge to a point at the focal point. And then this is a wavefront diagram showing that wave fronts. They're retarded more in the middle because the width of the lens is wider in the middle, but they bend more at the edges because of the obliqueness of how the light hits the lens. Okay, the second way of naming a converging lens is called a convex lens uh, because the outward edge of the lens is bent outward, so it's convex. Okay. Convex lenses are by far the most common. Numerous applications, including magnifying glasses, also called burning lenses. If you've ever used a magnifying glass in the sun, you know that you can burn leaves, burn paper. Camera lenses are all converging lenses. Your eyeball lens is a converging lens, and then far-sighted corrective lenses. Now, farsightedness means that you can see far, so you need help seeing up close. So reading glasses and bifocals, this lens right here is a converging lens. Okay, so by far, converging lenses are way more common. Now, this is how an eyeball works for a farsighted person. So the image would be produced way back here. So on the retina, the image would be blurry. So what the converging lens does is it takes the image and focuses it on the retina so you can see clearly. Okay, diverging lenses are so called because they bend light so that it diverges from a point. Um, so this again is the ray diagram. So the object would be over here and the image would be right here. on the same side as the object. They're also called concave lenses for obvious reasons. The shape of the lens is bent inward like a cave. They're not as common, so camera viewfinders, if it's a high-end camera, the viewfinder is supposed to give you a view of exactly what you're going to see in the field of the picture. And then movie directors use special objects that have concave lenses in them that help them to see exactly what the camera's going to see. And then if you're nearsighted, the corrective lens is for nearsightedness. Nearsighted means you can see stuff that's up close, but you can't see things that are far away. So the image is focused too near and out here in the middle of the aqueous humor, and so the concave lens will bend the light so that the image is produced right on the retina. Okay, now image formation. How exactly is an image formed? Okay, so there's some key terms that we have to get out of the way. First is the principal axis, which is right here, and it's perpendicular to the lens. So it's just an imaginary line. The focal point is where the beams will focus light, either converge or diverge to do that. The focal length is the distance from the center of curvature to the focal point. And then the image distance is how far away is the image from the lens. Okay, so in this case, the focal length and the image distance are the same. That's not always the case. It is rarely the case. And then the object distance is how far away the object is. And usually we describe that in terms of the focal length. Is it closer than focal length, in between the focal length and two focal lengths, or is it way farther than that? Okay, now two main types of images. First is a virtual image. Virtual image is like what a mirror image is. It's there, but it's not. It's kind of a phantom. It can be seen by the viewer, but it can't be projected on a screen. And it's right side up. It is probably different in size. Now, there's two ways of producing virtual images. One is with a magnifying glass. So when you use a magnifying glass as a magnifying glass, then you see an enlarged virtual image. Now, this is not a typo. It's produced by a convex lens if and only if, that's what IFF stands for, if and only if the lens is closer than f. When you use a convex lens in other ways, like in our eyeball, it's a real image. And then the second way of producing a virtual image is with a concave lens. So when you see an image that's right side up and different sized through a lens, then it's a virtual image. There's no way for you to project that onto a screen. Okay, the other type of image is a real image, meaning you can project it onto a screen. You can see it, the viewer can see it, and it can be projected onto a screen. The way to do this, secondly, the real hallmark of a real image, the reason it's called a real image is that it can be projected. But it's also upside down and backwards. Okay. So when you see something, the image that's projected onto your retina is upside down and backwards, and then your brain has to turn it right side up and uninvert it. So they think that the reason some people are dyslexic is that their brain has a hard time in doing that with letters. Okay. So you produce a real image with a convex lens if and only if the lens is at f or farther from the object. Okay, so if you take a magnifying glass and pull it far away from an object, you can actually project the image of that object onto a screen. And we're going to do this. I'll try to make a demo video of this kind of stuff, but we're also